everyone, and welcome to the ACSM Brown Bag in Science webinar. We're thrilled to have Dr. Michelle LeBlanc and Dr. Glenn Gaesser with us today as our guests. You'll hear more about them in just a minute, but first, let me tell you a little bit about the Brown Bag series. This year, we're highlighting ACSM regional chapters. We'll start each Brown Bag with someone from the regional chapter, a leader, a student, etc., who will tell us a little bit about some of the activities of the chapter. Then the presentation that you'll hear this morning will be from a member of the chapter. Today's presenter is a member of the Southwest Regional Chapter. A few housekeeping items to get us started. Our presenter will give us a 25 to 30-minute talk, followed by question and answer. Throughout the webinar, please type your questions into the question area on the GoTo Webinar screen, and we will take as many questions as possible after Dr. Gaesser's talk. If you have problems hearing or seeing the presentation, it's likely due to your internet connections. So please log off and log back into the webinar. We will record today's presentation, and within 7 days, we will send you the link to the recorded version. We will also place it on the acsm.org website. Our previous Brown Bag webinars are there as well if you'd like to view any of our previous presentations. So again, thank you for joining us today. I will now turn it over to Dr. Michelle LeBlanc, the immediate past president of the Southwest Regional Chapter, to tell us a bit about the chapter and to introduce Dr. Gaesser.
Good morning from the West Coast, past president for the Southwest Chapter of the American College of Sports Medicine. And our chapter was granted a provisional charter in 1981 and held its first annual meeting that same year. And we gained permanent chapter status in 1985. Our chapter includes memberships from California, Nevada, Utah, New Mexico, Arizona, and Hawaii. Most of our annual meetings are held in the Southern California area. We have about 400 active members in our chapter, and registration for our last face-to-face meeting was over 500. And our virtual meeting held in October was extremely successful. Actually, we had over 600 attendees. Our chapter really likes to focus on the student experience. We have a large attendance from both undergraduate and graduate students from our chapter. It is my distinct pleasure to introduce Dr. Glenn Gaesser, who's giving today's Brown Bag talk. Glenn is a professor of exercise science at Arizona State in the College of Health Solutions, and he has been there since 2008. And prior to that time, he was at the University of Virginia and UCLA. He's been an ACSM member since 1973 and a fellow since 1983. His research focuses on the effects of exercise and diet on cardiovascular fitness and health, and he's conducted more than 20 exercise training intervention studies in adults. His recent work highlights the positive effects of blood pressure and blood glucose control, of breaking up prolonged periods of sitting with physical activity of varying intensities and durations, and the impact of prior exercise on postprandial endothelial function after ingestion of a fast food meal. Today's talk, Can You Outrun a Bad Diet?, is certainly something that I think we're all interested in. And without further delay, I introduce Dr. Glenn Gaesser.
All right, thank you, Michelle. All right, you all should be able to see my slides right now. So we're going to be talking about this issue of outrunning a bad diet and where I get this idea to do this. Well, it's been an interest of mine for a number of years. One, because I eat, and sometimes my dietary patterns aren't all that healthy. I also run and do a lot of other aerobic exercise. I've often wondered what the interaction is. So I think that has relevance for a lot of people, particularly individuals that consume what might be called the typical Western dietary pattern that you see here, characterized by a lot of processed red meat, dairy products, a lot of highly processed foods, fried foods, sugar-sweetened beverages, and so forth. And so this is a dietary pattern that's very common, particularly in Western culture, including the United States. So it's estimated that about 95% of all major non-communicable diseases, diabetes, cardiovascular disease, cancers, and so forth, are due to food choice, toxic food ingredients, nutritional deficiencies. And you see the last item listed here, lack of physical exercise. So I've often asked the question, well, if all of these are related to poor health outcomes, what if we just tweaked one of these? What if we kept the diet pretty much the way it is, but tweaked the exercise portion of this? So I'm going to describe for you a few studies that we've done at Arizona State University here with regard to looking at the interaction between exercise and diet, particularly poor diet. But before we do, just to give you an idea of where this came from, really, if you take a look at this slide here, you'll see Morgan Spurlock of Super Size Me fame. He did this documentary about 15 years ago. It won all sorts of awards, nominated for an Academy Award. And for those of you that aren't familiar with this, essentially what Morgan Spurlock did was, for 1 month, just ate nothing but McDonald's meals, breakfast, lunch, and dinner, supersizing everything while keeping his physical activity level fairly low. He wore a step counter and accumulated no more than 5,000 steps per day while doing this. And as you might expect, he didn't fare too well health-wise at the end of the month. So I've asked the question, like, what would happen? What would have happened if he had exercised? Well, some researchers up in Canada actually addressed this. They had this paper published a few years back in which they basically duplicated the supersize me approach, but just for 2 weeks. So quickly, this is not my research. I just want to kind of set the stage for this question about whether or not you can outrun a bad diet. They had 13 young men consume for 14 days these value-added meals, breakfast, lunch, and dinner that were all value-added, meaning they had extra portions or supersized type portions for each meal. So for 14 days straight, they consumed 42 of their meals at McDonald's, similar to what Spurlock had done. But the difference is they did daily high intensity interval exercise, as indicated there, 15 times 1 minute intervals at 80% of heart rate max. And oh, let me go back. What you see here is just some of the overall effects in terms of the fast food diet and energy expenditure values. But the important thing is what happens to some of the physical characteristics. And I've highlighted some that were significantly different. Not only did body fat not increase, it actually went down slightly, as did fat mass here. So this suggests that you might be able to get away with, at least temporarily, consuming a fast food type diet, at least over the course of a couple weeks. In terms of metabolic cardiovascular characteristics, nothing much really changed. Fasting glucose actually dropped a little, as did LPA and the high sensitivity CRP. So those would be viewed as good things. One potentially bad thing happened, and that was HDL cholesterol actually went down. But the ending cholesterol of 1.35 millimoles is still over 50 milligrams per deciliter, which is probably not all that much to worry about here for these individuals. So yeah, the bottom line here is that it looked like, at least in the short term, high intensity interval training in individuals, young men, seem to be able to offset the negative effects of a fast food meal, unlike what Spurlock had shown. No control group here, very short duration, and only young, healthy men studied. So just keep that in mind as we're moving forward here. So one of the things that we've become very interested in our lab is the postprandial period, which can be very detrimental to cardiovascular health. And you see slides on the, or graphs on the left-hand side here, showing that after the ingestion of a high energy meal, you get increases in glucose and triglycerides over a few hours, And down at the bottom, you see increases in CRP and nitrotyrosine. So these are kind of markers of inflammation and oxidative stress that are increased during the postprandial period. And from our perspective, you get a decrease in what is called FMD, that's flow-mediated dilation. More about that in just a few moments. But you can see that the FMD here is depressed quite a bit during the first 2 hours postprandially. What this means is that whenever you eat something, eat a meal, you have the potential to create some deleterious postprandial cardiovascular metabolic effects. And since we spend most of our time in a postprandial period, this has consequences for our cardiometabolic health. So we're interested, as I mentioned, in the postprandial period, and not just from the perspective of exercise. Here are 2 studies we published in 2019, so about 14 months ago when these came out, where we looked at different combinations. The one at the top here was focused on glycemic index and cereal fiber, on postprandial endothelial function and glycemia and insulinemia in healthy adults. So we had 4 different meals to take a look at the potential differences in postprandial health. And down at the bottom here, we focused on adolescents, and we took a look at low and high fat meals with and without dietary fiber, high amounts of dietary fiber or low amounts of dietary fiber on postprandial health. So, and we demonstrated that the glycemic index as well as the cereal fiber seem to impact the postprandial period. So this is to show that even dietary factors can offset dietary effects postprandially. So the first study that we did that I wanted to talk about here in terms of postprandial health is one that was published just a few years ago by some graduate students and colleagues of mine at ASU. We did this study and asked the question whether or not high intensity exercise, particularly interval exercise, could prevent endothelial dysfunction after the ingestion of a high energy fast food meal. And so what we did is we took 13 healthy young men. We had them undergo 3 different conditions, a control trial, and 2 different interval type exercises. Now, the reason why we chose these 2 interval type exercises, the 4x4, which individuals spend 4 minutes at a high intensity with 3 minutes of active recovery, and then they repeat that 3 times for a total of 4 high intensity intervals, or the 16x1, which is at a similar intensity, but shorter intervals and shorter active recovery periods. And the reason why we chose those at the time this study was conducted, those were 2 of the more popular types of approaches to HIIT type exercise. So the high energy meal, the high fat breakfast meal, was from McDonald's. It was the big breakfast meal. It had eggs and sausage, bacon, hash browns, biscuit, and some milk that had 63 grams of fat in it. So prior to ingesting this meal, the afternoon before, we had them do the exercise, and then we sampled blood postprandially after the meal and also assessed endothelial function by FMD. So this gives you an idea of what the HIIT protocols look like. At the top, you have the 4x4 and the 16x1 with the time frame there in terms of the warm up and the intervals, the active recovery, and the cool down. The bottom panel shows you what the heart rate response looks like. And so we were successful in getting their heart rate up there in the desired intensity range. Now here's the assessment of endothelial function by flow-mediated dilation. And what you see here is the sonographer and a patient lying down. Blood pressure cuff is placed around the forearm and pumped up to a suprasystolic pressure so that it occludes blood flow downstream, down here. Ultrasound probe is placed over the brachial artery above the elbow. And we take images both before, under a rest, just a quiescent state, and then after it's pumped up and left in place for 5 minutes. And then, of course, we release the cuff pressure, and that creates a rapid flow of blood downstream to the extremity, down to the hand. And that increases, creates a shear stress that activates endothelial cell nitric oxide that leads to a host of changes, biochemical changes in the muscle that cause the artery to dilate. And so you can see on the right here, we have a screen that is from our ultrasound device. And what you see here is basically a image where we have the ultrasound recordings, and you can see we have the panel here is the diameter, this is velocity of flow, and this is the actual flow in units of blood, like mils per minute. And I can speed this up for you. Usually this goes about 5 minutes, but about 1 minute in, you'll see all of a sudden, about right now, the cuff is released, and here you see velocity increase and the flow increase. And then momentarily you will see the arterial diameter increase. And you can see the arterial diameter increases dramatically here, and over the next several minutes, you will see it gradually subside as the flow and velocity subside. So this goes on, we typically leave it in place for several minutes just to make sure we can catch the peak diameter. So we have a software package that basically does all the math for us, calculates the flow velocity as well as the arterial diameter at every point in time, and we calculate the FMD accordingly. So the FMD basically is calculated as the difference between the peak baseline, or the peak diameter, baseline diameter, divided by baseline times 100, and you get a percent FMD. And this happened to be 9.4%, and the range is about 7 to 15. So what happened in this study? So as I mentioned, we had them consume the high energy fast food meal. Blood glucose increased after each of the conditions. So the prior exercise, the day before, the afternoon before, had no effect on postprandial glucose concentrations over the 2 hours we were measuring here. Those asterisks just indicate they were different from the baseline value, but not different from each other. The same happened with triglycerides. The triglycerides increased from around 100 milligrams per deciliter up to about 175 milligrams per deciliter. But again, there were no differences between the groups. And here's the most important aspect of our study, the FMD. So you can see at baseline 1, this is the afternoon before, FMD was averaging around 5% in each of the conditions. After an overnight sleep and they arrive in the laboratory the next morning, you'll see that there's not much difference in the control trial. But in the 2 exercise conditions, the FMD has been increased substantially and significantly. So after they consume a meal here, at 30 minutes, 2 hours, and 4 hours later, here's where you see some significant separation between the control trial and the 2 exercise conditions. So FMD is definitely going down. There's undeniable evidence that FMD is falling. So it means that the exercise did not completely prevent some sort of deterioration in endothelial function. But you have to keep in mind, you're starting at a much higher level here. And never during the 4 hours postprandial did the exercise trials here fall below the baseline even of the control trial. So our conclusion here is that the high intensity exercise performed about 18 hours before the fast food meal seemed to attenuate, didn't entirely eliminate the postprandial endothelial function in these young men. So we think the effect might be associated with what we call the vascular preconditioning here, that exercise prior here boosted the endothelial function. So it kind of provided a vascular reserve, if you will. So we also note that the attenuation of the FMD was not dependent upon reductions in either the blood lipids or the blood glucose levels. So this seemed to suggest that exercise prior to just a really large, high-energy fast food meal seemed to provide some benefit from a vascular perspective. So now we ask the question here, can exercise affect postprandial fuel oxidation? So energy balance is a very important thing to consider. In other words, can you get fat by these things? Morgan Spurlock sure did, but the individuals who in Canada who went on that high fast food diet but performed exercise did not gain any fat. And it's well known that carbohydrate stimulates its own oxidation and suppresses fat oxidation. It's also known that chronic consumption of high carb diets without concomitant reduction in fat intake increases the likelihood of excess fat storage. And we also know that exercise has been shown to alter macronutrient fuel metabolism after the ingestion of a meal. But the role of exercise type and intensity is not all that well established. So what we did, I had a master's student in nutrition that was interested in this topic. And he rounded up 10 subjects, volunteers, 8 men and 2 women, who had 3 different conditions, each on a separate day, approximately about a week apart. And they consumed 2 glazed donuts on each trial, a total of 520 calories each. Control trial with no exercise at all. And then 2 exercise trials, one a high intensity interval exercise, very similar to the one I just described in the previous study, where they alternated 1-minute intervals at 90 to 95% of max with 1 minute of active recovery. But the difference here is they had to keep going until they burned 520 calories. And we were measuring energy expenditure all the time through indirect calorimetry. And so they went anywhere from about 38 to 80 minutes. That's a long range. So some of these individuals were doing up to 40 of these intervals over the course of the study just to burn the 520 calories. The moderate intensity was at a continuous heart rate about 60 to 75% of max, again, until 520 calories had been expended. And again, this took a very long time. Anywhere from about 40 to 100 minutes. And the reason for that is because the fitness levels varied markedly between the men and the women in this study. 2 of the women were very small, barely weighing 100 pounds. So even though they were fit, the amount of exercise they had to perform just to burn 520 calories took a long time. And then we took indirect calorimetry measurements both during exercise to confirm the energy expenditure and after exercise, and during a 5-hour postprandial period. And here's the timing of the data collection here. You can see for the 2 exercise trials, they came in the morning, had some baseline measurements. They did the exercise at about 8 o'clock. They ate the donuts at about 10 o'clock. And then they were studied for 5 hours thereafter with occasional breaks just to drink some water or to go to the bathroom if necessary. In the control trial down here, you can see that we allowed them to come in a little bit later on that day. But all the other measurements were exactly the same. They ate the donuts at about 10 o'clock, and then we had the postprandial measurements. So now for the results, if you take a look at the carbohydrate oxidation, just as I alluded to a few moments ago, carbohydrate oxidation in the control trial was increased dramatically from around 12 grams per hour up to nearly 20 grams per hour over 2 hours. And this is a well-documented finding. If you consume carbs, it basically augments the carbohydrate oxidation. That occurred to a minor extent in the 2 exercise trials. They started a little bit higher on those days, not sure why. It went up a little bit, but not nearly as high. And then after about 2 hours, the carbohydrate oxidation in both conditions, or all 3 conditions, subsided back down even below their baseline measures. And keep in mind, they were not eating anything after they had consumed the donuts in the morning. So the only meal they had the entire day was basically those 2 donuts. And then in terms of fat oxidation, we see the opposite picture. The control trial, as I mentioned before, when you consume something with carbohydrate in it, it will suppress fat oxidation, which indeed happened. It dropped from about 4 to 2 grams per hour. It slowly came back up, and that's probably due to the fact that they were already burning through their carbs and therefore needed some fuel to rely on. So they started oxidizing more fat. Whereas in the exercise conditions, you can see for both of those conditions, starting about 3 grams per hour, increased progressively over the 5 hours up to about 5 to 6 grams per hour. So if you sum all this up, I can show you what happens on the next slide. And here, if you look at the overall 5-hour balance for carbohydrate in terms of grams over the 5 hours, you can see that there were 62 grams of carb in the donuts. And that red line across the graph here is that 62 gram mark. So you can see in the control trial, they actually burned in the 5 hours more carb than they had actually consumed, about almost 18 grams more carbohydrate than they consumed. Whereas in the 2 exercise trials, they're pretty much spot on. By the end of 5 hours, they had pretty much burned through all the carbohydrates. But not so for fat. If you look at the fat oxidation here, what you see is that in the control trial, they were well short of the amount of fat that was consumed in the donuts. So they were short by almost 11 grams after the 5 hours. Whereas in the moderate intensity exercise, they'd pretty much burned through all of it, just shy by about a gram. A little bit less effective for the high intensity interval exercise, or about 5 grams shy. But there's no question that the 2 exercise trials postprandially allowed for the individuals to burn considerably more fat than had they just sat quietly with no exercise at all. So we can conclude that exercise increases the postprandial fat oxidation, and that the exercise, whether it's moderate or high intensity exercise, is not nearly as important as the total energy expenditure of the exercise, although the moderates seem to be a little bit better. Interestingly, though, the fact that 1 hour of exercise, and I say roughly 1 hour, it ranged from about almost 40 minutes to an hour and 40 minutes, was required to oxidize the amount of fat in 2 donuts that required only a few minutes to consume. So we gave them 5 minutes to consume the donuts, and no one took that long to actually go through 2 donuts. So this highlights the challenges of using exercise in terms of weight control in an obesogenic environment. So it takes you considerably longer amount of time to burn through calories that can be consumed quite rapidly. And the fact that during the control condition, 38% of the fat in the 2 donuts was yet to be burned even after 5 hours after consumption. You might ask the question, well, what happens when you eat again? And that's a good question. 5 hours later, these individuals are ready to eat again. So imagine doing this over and over and over again. You can imagine the surplus that might build up over the course of days or weeks or months. And this may have consequences in terms of weight gain. So now we're going to look at something a little bit different, long-term impact of indulgent food consumption. So we decided to take a look at donuts again. And this was a doctoral dissertation from one of my doctoral students, Wes Tucker, several years ago. And we looked at the effect of a donut supplemented diet with and without exercise training on a number of outcome measures, including fat mass, vascular function, aerobic capacity, and selected cardiometabolic markers. So this was the basically the design here. And you might say, why donuts and why 4 weeks? Well, donuts are very tasty. They're a great indulgent food, very popular. It's well documented that about 80% of Americans indicate that not only they like donuts, they consume them regularly, and 20% of Americans are in denial. So that's why we selected the donuts. Why 4 weeks? There's a large body of research that's been published over the last few decades that shows that weight gain, particularly in Americans, is not linear. Most Americans gain weight anywhere from about a ½ pound to a £1.5 pounds a year on average. But this is not linear. It typically occurs during periods of overconsumption around holidays. And there is this so-called holiday weight gain period from around Thanksgiving through New Year's that seems to be particularly important in terms of this so-called holiday weight gain phenomenon. So we selected 4 weeks because it's roughly that period of holiday weight gain. that occurs from late November through the end of December. So we chose 4 weeks, and we chose the donuts because they're a great indulgent food that are almost all fat and sugar. So here's the overview here of the consort diagram. We screened nearly 500 individuals. A lot of them were screened out because they just didn't meet the inclusion criteria. We whittled this down ultimately to the point where we had 9, 8, and 10 subjects respectively that were randomized into the 3 different groups. And the only difference between the groups, they all got supplemental feeding in the form of donuts that were provided to them. More about that in just a moment. But the 2 exercise groups got exercise in addition to the donuts. And then you can see that all of them that started out and were randomized actually completed the study. So again, here's the study design. They had 2 donuts a day, 6 days a week for 4 weeks. So we actually purchased the donuts at Dunkin' Donuts. It was fairly close to our laboratory facility. They were provided to the participants, usually 4 at a time. They ate 2 in front of the researchers at the laboratory facility. They took 2 home to consume the next day, and then they would come back for another foursome and then another 4 donuts. So we did this each week for 4 weeks. So the total was 48 donuts. Dunkin' Donuts publishes a calorie chart. So we were able to determine that the donuts amounted to about 14,500 calories, mostly fat and sugar during this period of overfeeding with the donuts. And we allowed them to select various donuts from different charts according to the calorie content of the donuts. But most of them totaled right around 14,500 calories. The exercise was all supervised, 4 days a week, 250 calories a session, which totaled 1,000 calories a week. And so all of them were supervised. We knew what their VO2 max was. We knew what the power output on the ergometer was, so we could determine with a fair degree of accuracy the estimated energy expenditure of the sessions. And again, we had the high intensity interval exercise and the moderate intensity continuous, similar to the previous study I just described. They also were encouraged to maintain their regular diet and physical activity level. More about that in just a moment. And then the outcome measures were assessed at baseline and after the 4 weeks. So this slide here shows all the measurements we took, all the assessments, baseline and at 4 weeks. And you can see the level of confidence and accuracy for virtually all of them was very high because these are very good techniques. We've got a lot of data to show that they're very reliable and accurate. The ones down at the bottom, the daily physical activity level and energy expenditure via accelerometry, low to moderate, they've been basically validated with doubly labeled water techniques and so forth, but they're still not extraordinarily accurate. And then the daily energy intake by the diet record, very low confidence in terms of accuracy. Those are notoriously inaccurate in terms of a quantitative assessment. So we measured VO2 max, and you can see that the 2 exercise groups improved as you might expect. No surprises here at all. Here are the changes in weight, fat mass, and lean mass. So if you look at the far left, this is the body weight here for the 3 different groups. And it's the control group on the top, the moderate intensity on the bottom, and the high intensity or in the middle, and then the high intensity on the bottom. The fat mass and lean mass are identical in terms of their setup. So each participant is rank ordered in terms of weight change on this left-hand side over here. The fat mass and lean mass are the same subject. So you can see the order of weight change, some lost, some gained weight, but it wasn't extremely highly correlated with the changes in fat mass or the lean mass. So that's something to be cognizant of. Now, the theoretical change in energy balance would be like it's indicated here, and this is just totally based upon the calorie content of the donuts and the calorie content of the accumulated exercise sessions. So we definitely expected more energy balance in a positive way with the control group. This is the actual changes in body fat with the energy balance with regard to DEXA. So we did DEXA scans. We assumed about a little over 1,100 calories per kilo for lean mass, 9,500 calories per kilo for fat mass. You do the math on that, and the only group that changed was the HIT group had a trend for an increase in energy balance. The other two, not so. And you can see with large error bars there, there was a lot of individual variation. And this shows the individual changes in energy balance for the subjects for the different groups. And you can see just quite variable. Even in the control group, we had half the subjects basically lost energy, go figure, with the extra donuts, whereas half over here actually gained. And a lot of variability in the moderate intensity and high intensity groups as well. This is the actual change in fat mass. And we expected a significant increase in the control group. That did not happen. Oddly enough, the HIT group, which is the group we probably would have expected to be least affected by this, actually had a trend for a significant increase in fat mass in the HIT group. And the change in lean masses were indicated here as increasing slightly in the control and HIT group, no change in the moderate intensity group. Now, we monitored 3-day diet records at the beginning and at the end, and you can see here that when you do this, and we basically did 3 days before they started the study and then 3 days during the last week, and we just assumed a linear change throughout. So there's a lot of gray areas here in terms of our the fidelity of measurement here. The bottom line is that it looked like the moderate intensity and high intensity did not really change, but the control group seemed to have a down regulation in their habitual energy intake, even though we told them not to change. It could be just due to the fact that they consumed the donuts and it dropped. This is averaging about 239 calories a day, about 47 grams of carb in terms of the control group. And if you look at the total energy expenditure, again, this is a crude estimate based upon our body media SenseWare accelerometer. So this measures, activity energy expenditure, daily steps, and the amount of time you spent in moderate intensity activity, vigorous intensity activity, and sedentary. And again, there were no significant changes, although you can see that the variation there by the standard deviations, there are huge individual differences across the individuals. So if you take the self-report dietary data and you take the data from the accelerometers, plus what we know we fed them in terms of the donuts and the energy expenditure of the exercise sessions, you put that all together, and over here, they should have had somewhere around an 8,000 to 9,000 calorie increase in body energy content. That's what should have happened based upon our estimates. Again, the donuts and the exercise training, pretty good estimates there. We're confident in those measures. Habitual energy intake or energy expenditure, not so much. When you put that all together and look at the individual data, you see energy compensation is fairly notable in at least 2 of the groups, the control and moderate intensity, which means that somehow they basically downregulate energy intake or outside physical activity in some way to compensate for the extra energy coming in from the donuts. When you look at the cardiometabolic measurements, you see 2-hour oral glucose tolerance. Not much going on here except the control group, oddly enough, and the moderate intensity group both seem to do slightly better after the training. Now, why the control group might have got slightly better is just totally puzzling to us. But these were not extraordinary changes. The HIT did not change at all. And when you look at the integrated area under the curve, now you see the control and moderate intensity decrease, which is odd. that you would expect, that you would not expect the control group to have benefited by consuming more donuts without the exercise. Insulin, nothing happening here at all, just a couple minor differences, but overall the insulin values during the OGTTs were not really changed that much. The most important finding that we found that was not really a non-finding, the one that just surprised us the most, is that the flow-mediated dilation did not change significantly in any group. Even they slightly trended downward. And this was surprising to us because we would have fully expected, based upon prior data, that the control group might have decreased a lot and the hit in moderate intensity might have either not changed or increased. All right. So why is this important to us? Well, what went wrong with this diet first? The supplemental supplementing habitual diet with the extra calories, about 14,500, was not sufficient to induce any deleterious changes. We did not see anything go wrong in our subjects, which means our hypothesis was just basically shredded. And exercise training did not improve endothelial function. And that was one of our findings that was surprising to us. And if we look at the compensation in terms of the habitual diet of the individuals, it seemed to indicate that they would downregulate over the 4 weeks. So feeding them the donuts seemed to suggest that they ate less throughout the day on the days they ate the donuts. And this reduction, as I indicated before, about 47 grams a day, was mainly from decreased sugar intake. So more than half was from sugar intake. And there's about 30 grams of sugar in the donuts. So it could be that this was just entirely offset when we fed them the donuts. But what about the lack of improvement in endothelial function in the training groups? This really surprised us. We expected actually an improvement to go on here. And why? We did a study that was published several years ago where we had the exact same training protocol. We had a moderate intensity training and we had a high intensity training. The training protocols in this study, published back in 2016, identical. It went 8 weeks. There were no changes in diet. This was just exercise alone. And you can see what happened here is VO2 max, this improvement after 4 weeks, identical to what we just showed with the donut study. The FMD, you can see here, no change in moderate intensity, which is a little bit surprising to us, but we had a significant improvement in the FMD in the HIT, even after 4 weeks where we saw nothing in the donut study. So let's get back to this original question here, and we can wrap this up and open it up for questions. Can you outrun a bad diet? Well, in the context of a single meal, probably. What about long-term? Maybe, although some of our outcomes were suggestive of maybe some interactions here that need further assessment. We also think that there might be some alternative research questions that need to be asked. One very important one, are 2 donuts a day bad enough to make a bad diet? So we selected 2 donuts, be about 600 calories on average for the donuts, to be reflective of something that is more translatable to the typical American. I mean, the Morgan Spurlock approach, where you consume a supersized McDonald's meal 3 days, 3 meals a day, 7 days a week for a month, is just totally unrealistic. And many of the other studies in this regard have had individuals consume large amounts of food. And we thought that this might be more translatable. Another interesting thing is that I might revise my title to have an alternative one, and that is, can a bad diet, i.e. the donuts, prevent the beneficial effects of a good run? So with that, we'll open it up to questions.
All right. Thank you, Dr. Gaesser. That was a really interesting presentation. I don't know if we all want to go eat donuts or never eat a donut again. I'm not sure, but we're all thinking about donuts. So I want to let everybody know you can go ahead and enter questions into the area on the GoTo Webinar platform. We'll do some questions with Dr. Gaesser. If anybody has a question about the Southwest chapter in particular, Dr. LeBlanc is still with us, so she can answer some questions too. So our first question is, can you remind us in the first study about how active were your subjects before the study started? Were these regularly active people, or were they mostly sedentary?
In the first study, where we looked at the effects of the fast food meal on postprandial endothelial function, they were ranged from sedentary to moderately active. So they were generally non-obese individuals, but had a reasonable level of physical activity. The second study on the donuts, those individuals range from your active to fairly active individuals. In the last study, they were inactive. We had them wear accelerometers to make sure they actually qualified for the study. So we particularly in the last study focused exclusively on sedentary, overweight, obese men that were inactive.
Great, thank you. Our next question is, do you think that outrunning a bad diet depends on the individual's fitness and or weight goals?
I don't know that it depends so much on fitness. I think it depends on activity. There have been some studies that have been conducted that are very similar in design to the one that I showed you, for example, with the donuts on postprandial fuel metabolism. And fitness didn't matter, but exercise did. So when you look at very fit subjects or unfit subjects separated out by, let's say, cardiorespiratory fitness, VO2 max, they seem to have similar postprandial responses. So it's largely a matter of the most acute, recent exercise bout and not necessarily fitness per se. So I think there's obviously, you look at some of the data we showed you on the individual responses, there's a tremendous amount of individual variation in all the studies we've conducted. So I'm not sure how applicable it would be to just translate this across the board to everyone. But the data do seem to suggest that exercise can have a pretty powerful effect on mitigating some of the harmful effects of the typical American diet.
Great. So we have some folks who are wondering in the more recent study that you described, the 4-week study. How did you get the folks to adhere to the protocol? Basically, that was actually quite impressive that you got people to come in and do exercise for 4 weeks and eat all the donuts.
Yeah, well, we have an IRB that requires us to have, in the consent form, full disclosure on what they're getting into and what the potential hazards or risks of the study are. So it's not all that difficult to have individuals volunteer for these kinds of studies. I mean, the subject burden is actually quite low. Of course, they have some measurements on the front end and the back end of the study. But other than that, they're coming in basically 4 days a week for the exercise. The sessions typically only last about 30 minutes or so. So it's not a huge imposition in terms of time. They do have a financial compensation, a modest one, to complete the study. As far as the donuts are concerned, yeah, full disclosure, we said, look, you're going to be consuming 48 donuts over the next month. They're just going to have about 15,000 calories in it. Are you willing to do this? And those that say yes, they're in. And just to try to make sure they're as compliant as can be, is we did buy the donuts for them fresh each day when they came into the lab. So we have every reason to believe they did follow through on consuming the donuts. So this is always a problem in these kinds of studies. It would have been ideal to have them basically in a metabolic ward for a month, but then they can't do their normal life. I mean, if they work, if they're students or whatever, you can't have that kind of study. So you do the best you can, and that's what we tried to do.
Great, thank you. Can you explain just a little bit about how carbohydrate consumption suppresses fat oxidation?
Yeah. Yeah, it's basically, carbs are very rapidly absorbed, much more rapidly than fat. So, and they create an insulin secretion, and insulin is lipogenic. So insulin will actually promote fat storage. And glucose, and insulin also promotes glucose uptake into cells. So what happens here is that it's basically a matter of when you consume a meal that has glucose, or any carbohydrate mixed in with fat, glucose basically takes charge by getting into the circulation first. So it basically dictates the oxidation pattern that occurs. And it doesn't matter if you consume a complex carb or some refined carb, if it's sugar or we're not. We see the same thing. We did another study where we had individuals consume a 20-ounce soda, a sugar-sweetened beverage, and a candy bar, and you see the same response. So carbohydrates generally increase their rate of oxidation, and just by doing that, they suppress fat oxidation. So this has been well documented. It happens in young people, old people, men, women, low fit, high fit. There is no getting around it. This happens in everyone to varying degrees. And I really think a lot of the obesity prevalence increase we've seen during the last several decades in the United States stems from the fact that, relatively speaking, our carbohydrate consumption has increased, but we've had no decrease in fat intake. So this creates a recipe for carb burning and fat storage. And without exercise going along at the same time, you've got a recipe for obesity. And there's no question that I think that has contributed in large part to the rising obesity prevalence that we see in the United States that you may not see if you had an extremely active population.
Great. I'm gonna give you two questions that are sort of related. So the first one is, will we see a study done focusing on people who have metabolic issues or insulin resistance? I'm curious how this study would affect those who suffer from those, from conditions like that. And I was also curious, would you expect to see something similar or different in, for example, an older adult who may already have some endothelial dysfunction?
Yeah, those are great questions. Absolutely great questions. And honestly, I don't know the answer to those. My feeling is that the effects that we have seen in the 3 studies that I just showed you, I think you would see those in older individuals and even in individuals with metabolic dysfunction of some sort, like either prediabetes or diabetics. But again, that's only my assumption there. We chose healthy subjects initially to do this on because we wanted to have basically a proof of concept. But you're absolutely right, because there's no question that individuals who have cardiometabolic disorders, such as diabetes, don't really have that healthy a diet. So this so-called Western dietary pattern is basically ubiquitous across cultures, Western cultures, across all age groups. So whether the results of our studies would be able to be reproduced in those populations, particularly older individuals or older individuals with cardiometabolic disorders, great question, remains to be done.
Great. So we're going to have time for a couple more questions. This one is, given that low socioeconomic status is strongly associated with a poor diet, is it appropriate to ask, can you outrun your SES? Any data on the effect size moderation by SES?
I have not, for these types of studies that I just described, no, I don't. However, I am aware of some studies on youth, particularly the Hispanic youth. And there seems to be a similar type of benefit for exercise in these populations. So yeah, it's a great question. And I really think the results that we showed here could be extrapolated to different populations. might be some subtle differences there, but in broad strokes here, I think you would be able to duplicate this, at least qualitatively.
Great. The final question, we always like to sort of make some translation if possible for our folks who are listening who maybe work with individuals in a fitness professional, fitness setting, or medical rehab setting. What sort of advice might a personal trainer, for example, give to their client around eating and exercising and timing of it all? Do you have any suggestions from the work that you've done so far?
Yes, and I'm glad you asked that question. I get that frequently as well. I mean, why do this? Why study the effects of donuts or a fast food meal on your health? And the answer is just pretty straightforward. Americans eat a lot of that kind of food. And we have dietary guidelines that are released every 5 years. From 1980, Congress mandated that the USDA and Department of Health and Human Services put out dietary guidelines every 5 years. The 220 guidelines were just released last fall. And if you look at those guidelines, there is a huge disconnect between what is recommended and what Americans actually consume. So Americans fall far short of consuming the recommended amount of fruits, vegetables, whole grain foods, and so forth. And it hasn't changed all that much. So I asked this question from a very pragmatic sense, in that if Americans seem relatively unwilling to change their diets, might we just focus on the exercise and let them eat what they want? Now, it's not like giving up on the diet aspect. I've published studies showing that dietary affects endothelial function and cardiometabolic health as well. So I'm not saying that diet is not important, but this is more of a pragmatic question. So, typically we tell people, yes, the key to good health is exercise and a healthy diet, amongst other things, but the diet and exercise. But the purpose of this was just to basically ask a fundamental research question. What if someone is unwilling to give up some of their indulgent dietary pleasures? Is all lost? And our studies seem to suggest no, that you probably can consume indulgent foods occasionally, maybe even 2 a day for a month, and not have 2 donuts a day for every day for a month, and not have any real harmful deleterious effects. Now, I'm not saying to just give carte blanche to this concept of diet doesn't matter. The point to be made here is that it does matter, but if a lot of Americans are unwilling to change their diet, exercise seems to have a beneficial effect that it seems to be not contingent upon that positive change in the diet. So this is really a pragmatic question.
Great, thank you so much. We want to thank Dr. Gaesser again for a great presentation. We also want to thank Dr. LeBlanc for being with us today. You can learn more about the regional chapters at the ACSM.org website. And finally, we just want to remind everyone that the ACSM Health and Fitness Summit is coming virtually in April this year, April 7th through 11th. Registration is open now, and early bird registration is open through March 15th. So with that, we'll say thanks again to our presenters. Have a great day.